Morning students, today we are going to discuss the topic on Java multithreading from the course Object Oriented Language using Java. So let us take the recap first, from the previous class what we have discussed. Have you ever opened multiple apps at once on your mobile phone? And have you run multiple tasks in parallelly, like similar to Java multithreading? And here the objective is to understand how Java is handling the multiple threads simultaneously. So let's take the problem statement of a person like a student like Anita. She is building her multi-user application, and she's facing a challenge of program which she's handling one request at a time, and it is giving slow response. And here is the goal to enable the concurrent execution of multiple tasks. When you work with one particular application, it may be showing up the speed up and in effectiveness and efficiency, but when you handle more than one application, you may find the response time uh, it becomes very poor. So in such situation, how Anita is facing, and what solutions can be provided to her. So before going for the solution, let us understand the thread first. Whenever the thread occurs, what happens to the programmer? The program feels frustrated of the execution because of lagging of the program, and also there must be a better way to handle the multiple tasks. The programmer has to think. Maybe the programmer find a reason how it can be prevented, how it can be recovered, what are the programming techniques can be implemented. The programmer can think, and then the programmer has to see the CPU also, whether the CPU is idle. When many tasks are provided, or many tasks are in the queuing, or then the programmer sometimes it looking for solutions to through programming method in Java. And here the insight is, we need to find a concurrency control execution, and also to find a very efficient task management when we have multiple tasks to execute. Also, we need to define the thread with a more detailed understanding. So here the problem is sequential execution causes performance bottlenecks, but the goal is to enable programs to create and managing multiple threads for concurrent execution. So here it is. If you think to execute thread by thread, it may provide some kind of bottlenecks. Okay, so we need to have parallel execution. Maybe the thread execution can mutually be excluded. There could be a swapping or a context switching between one thread with another thread. So here you can see the diagram. It is being explained with through two threads, how the two threads are sharing the memory in the CPU execution. So the IO weight is the input output weight. So the arrow marks which is explaining the context switching with one thread with another thread. So the approach of here to handle the threads, let us brainstorm uh, how in programming the threads has been explained. Okay, we can use the extends keyword in the programming method, or another keyword like implements runnable interface, and one more method where we can have executor service. That's an advanced method. However, the first two methods are very easy to understand. Which method would you use for your 50 parallel tasks? Just assume it is a kind of role play. And two ways to create the thread, it is explained. No, one is using extending class, other one is implementing runnable interface. So here you see that this example is with the use of extends keyword. So you need to define a class, and then class name followed by the extends keyword, and then you can have a run method by processing the thread message the thread is running. Another method where another class where it explains the demo how the new object variable is created t with the method my thread. So let us see the another example of runnable keyword. So here the difference in the code with the previous code is the keyword here it is we used implements runnable, and the method is run, and you can see the difference in the object creation statement. So in the previous program the object has been just created with empty arguments, but here it is the object has been created t with the thread passing the argument is runnable method. So here the cycle of Java threading and runnable interface is explained, where you can see that create threads, runnable interface, decline and manage threads, running tasks, etc. So how the thread has been engaged. There is one activity, write a program with two threads. One prints the numbers between 1 to 5 and another prints letters A to E. So these two things you have to make it as a single program. And another activity task is given to you is to discuss when to use thread.sleep method for the synchronization. So also that there is a quiz questions for you. Which interface defines the run method and what is the difference between the start and run methods, you have to explain. So multi-threading usage in real time, it is used in servers, simulation, parallel computing, okay, and it is also used in reactive programming. Uh, so every thread has its own life cycle, synchronization, and priorities. So that's where that this is called Stanford T model. And here the assessment for reflection and peer sharing. You have to form a team of people, three people. How does multi-threading improve your user experience and what issues arise if threads are not synchronized? And you have to encourage linking thread using to real world apps like chatbot or downloaders or sensors. So you have to think, then you have to discuss by pairing with others, then you have to share your views on that. So here the summary, finally the various fundamentals we have discussed so far, and we know how to create thread using the keyword extends and runnable interface. Also we have touched that thread priorities and controls, how it can be possible in future. So this is where we are moving on to the topics and the assessment here on real-time scenario. In what kind of real-time application is multi-threading is essential and why would a single threaded model fail there? And you can take a task, define thread lifecycle with a neat diagram. You can make your own diagram. And also one situation is given to you when in a media player application, downloading the songs and updating the UI must happen concurrently. So you have to explain how you would implement this using Java threads. You have to suggest how priorities might be managed between the threads, like which can be given minimum priority, which can be given low priority, like which can be given normal priority, like that. Fine students, thanks for listening and we continue in the next class.